Okay, let's talk about 5.6. I'm sorry I won't be there for you today, but it is what it is. One of the reasons that we focus on factoring is it's really helpful for us to solve quadratics, and then as you get into higher math, solving higher order polynomials. But the way we can do this is we have to, first of all, figure out if it's a quadratic. A quadratic equation is basically an equation that has a degree of 2 with a single variable. If it has a degree of 1, it's a linear equation. If it has a degree of 2, it's a quadratic. 3 is cubic, and it goes on from there. The degree tells you how many solutions there can be. So there can be either 0, 1, or 2 solutions to a quadratic. And again, as you get into higher math, there will be more explanation on that. But here's why factoring is important for doing this. The principle of zero products tells us if you have two things multiplied together and they equal 0, then the only way that can happen is if one of them is 0. So if you are multiplying two things and it equals 0, then one of them has to be 0 in order for the product to be 0. That's the only way you can get 0 through multiplication, is if you multiply by 0. Okay. So in general, what we're going to do is we're going to take an equation, we're going to set it equal to 0, make sure it's equal to 0, we're going to factor it, and then each of the factors has to be, we set each of those equal to 0, and that will give us our solutions. Okay, so that in general is what we're doing here. So let's just do some, and let's see if I can. Oh, here we go. I couldn't find the button I was looking for. All right, so we're going to use the zero product principle and solve this. So what the principle tells us, if we have something equal to 0, we have two things multiplied times each other. So this is the equivalent of A times B equals 0. So A equals 0 or B equals 0 based on the principle. So that means that x plus 4 is equal to 0 or x minus 3 is equal to 0. And now we just solve each one of these. Well, of course, to solve this, I'm going to subtract 4 from both sides, and I get x equals negative 4. Here I'm going to add 3 to both sides, and I get that x is equal to 3. So now remember, you can have either 0, 1, or 2 solutions, and it looks like this one I have 2 unique solutions. But also notice in the instructions it says check your solutions. That means I have to check twice. Okay, so if I do this, what it means here is I'm going to replace x with 4, negative 4. And I want to see if it's equal to 0. So negative 4 plus 4, negative 4 minus 3, that gives me 0 times negative 7. That does equal 0. So this checks. I'll do the same thing with x equals 3. So, whoops, and I forgot to close my parentheses. So I want to know if 3 plus 4 plus 3 minus 3 is equal to 0. Well, 7 times 0 is 0, so this also checks. Now, I think in my lab they will ask you to write your solutions as a set. So the solution set is you use a set bracket and you just list your solutions. Well, now the zero product, or the principle of zero products, extends to more than two things. If you have five things multiplied together and it equals zero, one of them has to be zero. Okay, so here I've got 1, 2, 3. So I've got three different factors in my product. So I have 5 equals 0, or 3x minus 7 equals 0, or x minus 6 equals 0. Well, 5 can never equal 0. That will not help me get to what the values are of x are that make it true. So let's just solve and check each of these other solutions. So if 3x minus 7 equals 0, or x minus 6 equals 0, here of course I add 7, and that gives me 3x equals 7. When I divide by 3, I get x equals 7/3. Here if I add 6 to both sides, that tells me that x equals 6. Okay, so now the check on this, let me do this one real quickly because then I can figure out how much space I need later. So for my check, I want to know if 5, 3 times x minus 7 times x minus 6, if that equals 0. Well, this gives me 5. 18 minus 7 is 11. 6 minus 6 is 0, equals 0, so it checks. So x equals 6 is a solution. Okay, then I'm going to use all this space down here for the 7/3. Okay, so now I want to know if 5 times 3 times 7/3 minus 7 times 7/3 minus 6, if that equals 0. Okay, well this gives me 5 times, and this gives me 7 minus 7 times 7/3 minus 6 equals 0. So this is 5 times 0 times 7/3 minus 6, which does equal 0, so this also checks. So my solutions would be 7/3 and 6. Okay, now I'm hopeful at this point that you will stop and try some on your own as you're watching the videos. Okay, I still have two chunks here that multiplied together equals 0. So I have 9m times 2x minus 5 equals 0. So that tells me that if the product is 0, 9m equals 0, or 2m plus 5 is equal to 0. When I divide by 9, I get m equals 0. Subtract 5 gives me 2m equals negative 5. When I divide by 2, I get m equals negative 5/2. Now, to make sure that we have done it correctly, we're going to check our solutions. So I want to know if 9 times 0 times 2 times 0 plus 5 is equal to 0. Well, that's 9 times 0 times 5 equals 0, which it does. So m is 0 is a solution. Okay, so now I want to know if 9 times negative 5/2 times 2 times negative 5/2 plus 5 is equal to 0. So that 9 times 5 is 45, so that's negative 45 over 2 times negative 5 plus 5. Well, this is 0, so that one also checks. Okay, again, I hope you will try this one on your own. 3p times p minus 11 equals 0. Since the product equals 0, that tells me 3p equals 0 or p minus 11 equals 0. Oh, and before we go, let me write our solution set. 0, negative 5 halves. Okay, if 3p equals 0, when I divide by 3, that tells me p is 0. Or you can just use the principle of zero products. If 3 times something equals 0, that has to equal 0. Here, if I add 11 to both sides, I get p is equal to 11. So now I check. All right, so 3 times 0 minus 11 gives me, I want to know if that's equal to 0. 3 times 0 times negative 11 is equal to 0. So that checks. Let's check 11. So 3 times 11 minus 11, I want to know if that's equal to 0. So 3 times 11 times 0 equals 0. Yes, it does. So my solution set is 0, 11. Okay. So all of these were given to you in factored form, and if they're in factored form, then all you have to do is set up the split them up and find the solution to each linear equation, then of course check your answer. But here's why we spent all that time on factoring. It's because a lot of time we're going to give it to you in expanded form or standard form. So here's what has to happen, and in this order. It has to be equal to 0 before you do anything. Okay. Then you're going to factor the polynomial, set each factor equal to 0, and then check. Okay, so it must be equal to 0. It equals 0, so that part is done. Now I'm going to factor it, which means since my leading coefficient is 1, that means I'm looking for two numbers whose product is negative 6 and whose sum, that's positive 6 and negative 5. And that is negative 2 and negative 3. So this factors into x minus 2 times x minus 3 equals 0. And don't forget that 0 when you're writing it down, because that's what allows you to do this. Okay, so I have two things multiplied together that equal 0, which means one of them has to equal 0. So x minus 2 equals 0, or x minus 3 equals 0. So that tells me that x equals 2 or x equals 3. Okay. Now for your check, I want to make sure you put up here, you want to check in the original equation. This is really important because if you factored it incorrectly, if this is wrong and you check back into this, then you're still not checking in your original equation. So check in the original equation. Alright, so I want to know something squared minus 5 times something plus 6 is equal to 0. So 2 squared minus 5 times 2 plus 6 is equal to 0. That gives me 4 minus 10 plus 6 equals 0, which it does, so that's a solution. Okay, now I've got to check 3. I want to know 3 squared minus 5 times 3 plus 6 is equal to 0. oops, that's a 2. So 3 squared minus 5 times 3 plus 6 is 0. 9 minus 15 plus 6 does equal 0. So this one also checks. And your solution set would be 2, 3. Okay. All right, let's try x squared plus x equals 12. Okay, this does not equal 0. Not equal to 0, so I have to fix that. And I can do that very easily by just subtracting 12 from both sides. So keeping it in descending order, that's going to give me x squared plus x minus 12 is equal to 0. Okay, so factored form, this tells me I'm looking for two numbers since the leading coefficient is 1. Two numbers whose product is negative 12. Those same two numbers, their sum is 1. And that is 4 and negative 3. 4 and negative 3. So this is x plus 4 times x minus 3 is equal to 0. I think I'm writing too big. All right, so that tells me x plus 4 equals 0, or x minus 3 is equal to 0. This tells me that x is negative 4. This tells me that x is 3. Okay. So I'm going to go back and check in the original equation, because I may have made a mistake somewhere along the way. So I want to know if a value squared plus that value is equal to 12. So let's try the negative 4. Negative 4 squared is negative times negative, a positive 16. Minus 4 equals 12, and that checks. Let's check the 3. So I want to know if 3 squared plus 3 equals 12. This is 9 plus 3 equals 12. It does. So this is also a solution. And if I want to write it as a solution set, it's negative 4, 3. Now technically the order in here doesn't matter, but most people will put their solution set in numeric order. Then I threw my pen on the floor. Okay, so if I have 4x squared plus 10x equals 0, okay, it's set equal to 0. So now I just have to factor. But now I go back to my general strategy of factoring, and I notice that there are only two terms here. But the first thing I always want to do is check for a GCF. So it's set equal to 0. So my greatest common factor is 2x. So I'm going to factor out a 2x, and I'm left with 2x plus 5, and that equals 0. So this tells me that 2x equals 0, or 2x plus 5 is equal to 0. So x is 0. 2x equals negative 5, so x equals negative 5 halves. And again, I'm going to check those back into the original equation. So let's check 0. So 4 times 0 squared plus 10 times 0 equals 0. So 4 times 0, 10 times 0. This gives me 0 plus 0 equals 0. So that checks. Okay, so 4 times negative 5 halves squared plus 10 times negative 5 halves. I want to know if that equals 0. Okay, so negative 5 halves times negative 5 halves is 4 times 25 over 4 plus negative 50 over 2. So this gives me 25 plus negative 25 equals 0, which is true. So this also checks. So again, if I was asked to write this as a solution set, it would be 0, negative 5 halves, or the other way around. Okay, and again, I hope you'll try this one on your own. It's set equal to 0, so now I just have to factor the GCF equals x. So this is going to become x times x minus 5 equals 0. So either x equals 0 or x minus 5 equals 0. Okay, well x is 0, so that's done. Here, x minus 5 is 0, which tells me that x equals 5. Again, I'm going to check in the original equation. See if that equals 0. 0 squared, 5 times 0 equals 0. 0 minus 0 is 0, so that works. So now I want to know if 5 squared minus 5 times 5. So that one also checks. And my solutions are 0, 5. Okay, we'll change videos here.